Girls, let's start our unit on quadrilaterals and their properties. So let's start first with the definition of what is a quadrilateral. So a quadrilateral is a two-dimensional closed shape with four straight lines. We're going to see how we classify these quadrilaterals. So quadrilaterals. One type of quadrilateral are called parallelograms. Okay, and parallelograms have an important condition. Both pairs of opposite sides are parallel to each other. Okay, so and we have here the examples. So we have rectangles, rhombi or diamonds or squares. So if we think about any of these shapes, sorry girls, I left my drawing pad at home, so I have to do it by mouse. So this is not going to look very good, but that's okay. You're going to be patient with me. It says both pair of opposite sides are parallel to each other. So I have just drawn a side here. I'm going to draw another side. We can see these two are parallel, and then I'm going to draw the other two pair of sides here, and we can see that these two are parallel to each other. Therefore, these ones types are what we call parallelograms. And I just drew a rectangle, but if I do a rhombus, it will have the same condition, or if I do a square, it will have the same condition. Wonderful. The other type of quadrilateral are the ones that are other quadrilaterals or non-parallelograms. So, and these ones are trapeziums, irregular quadrilaterals, or kites. So if we think about it, if I draw a trapezium, so let's do it with these two. So if I do a line here, we can see that the ones that I'm drawing at the moment are parallel, agree? But the ones that I'm going to draw now are not parallel to each other, because if I extend them and continue this line, if I extend it, it's going to cross at a point with the extension of this other side, which will not happen if I extend this green one and this green one forever and ever and ever. They will never cross. That means that they are parallel. But in this case, I have only one pair that are parallel and the other two are not parallel. So therefore, these are not a parallelogram. Great. A very important property of angles in a quadrilateral is that the sum of its angles is always 360. Okay, so let's remember that when we did triangles, we said that the sum of the internal angles of a triangle always add up to 180 degrees. So in a quadrilateral, what happens is that it will always add up to 360 degrees. So if we look at this, an example here, we can see here I have a quadrilateral drawn. We can see that this quadrilateral that I have here is not a parallelogram. It has four sides, but it's not a parallelogram, okay? It's an irregular quadrilateral. And if I split it in half, I get two triangles. And we know that each triangle, the internal angles add up to 180. Therefore, the two triangles will be add up to 360. And we can write this by writing like this. The internal angles of any quadrilateral, if we call them A, B, C, and D, those internal angles, they will add up to 360. Wonderful. Okay, now focusing on that first group that we talk about quadrilaterals that are called parallelograms, let's look at what type of parallelograms do we have. So I want you to draw this table that we have here. So wonderful. So the first type of parallelogram that we have is called a parallelogram, and the properties are that opposite sides are equal in length and opposite angles are equal in side. So we are going to highlight, and I want you to do this in your notes. I'm going to add a pen here, a highlighter, and I want this color to be, I want it green, okay. So I want you to highlight this. Opposite sides are equal in length and opposite angles are equal in size. Okay, so we can see here that opposite sides are equal in length. So if I use yellow, we can see that this side and this side measure the same, and we know that this is marked with two lines here, symbolizing that they have the same length. And the same here, if I look at this opposite side and this other opposite side, they measure the same, symbolized by this mark here. You're doing this with a ruler, so that is very clear that it is. And then it says opposite angles are equal in size. So if we see here, this angle and this angle over here are equal in size. They are opposites, and it's symbolized with only one mark. And we can see here, I'm going to do it with another color just to make it more clear. Two lines, two marks here to mark this angle, and the opposite one, the one that is across, measure the same. Okay, and these are properties of parallelograms. Now let's look at another type of parallelogram. Let's look at rectangles. So rectangles, the opposite sides are equal in length, so the same as with the parallelogram, but all angles are the same and equal to 90 degrees. Okay, so we can see here, I'm going to do first the angles. We can see I have a square here and another symbol here and the same symbol here and the same symbol here to show that these angles are 90 degrees. But we can also see that opposite sides measure the same, and I know that because I have these two marks in here that symbolize that these two opposite sides measure the same. And if I do it with green here, I can see that it's with purple. I can see that this side measures the same as this one, symbolized by that mark. Wonderful. Let's look at another type of parallelogram. So rhombus. In the rhombus, all sides are equal in length. So here I have all sides that are equal sides, but opposite angles are equal in size. So in this one, what I have here is that all sides measure the same. Here, all sides measure the same. But if we focus on the angles, what I find is that the opposite angles measure the same. So this angle and the one across measures the same. And let's do it with blue here, this one. And this angle here and the opposite across measure the same. Wonderful. We have one more type of parallelogram, and it's a square. So in a square, what happens? And we're very familiar with a square. So all sides are equal in length, the same as with the rhombus, but all angles are also the same, and they are 90 degrees. Okay, and we can see this in the graph here. We can see our right angle symbolized by that little square here in all the four corners of our square, and we can also see that all sides measure the same. Wonderful. Let's look at types of other quadrilaterals. So the second group that we talk about in our first diagram that we had. So one type of other quadrilateral that we have is trapezium. So let's see what are the properties of the trapezium. It says one pair of opposite sides is parallel. So we have this by this symbol. This arrow here is saying that this line and this line are parallels. Okay, so when we have only one pair of lines that are parallels in a quadrilateral, this is called a trapezium. Now let's look at our second type, a kite. So in a kite, two pair of adjacent sides are equal in length. One pair of opposite angles are equal. So I'm going to explain this. Two pairs of adjacent sides. What does it mean adjacent? It means next to. So which ones are in this case? I'm going to do it here with green. This side that is adjacent next to this side, they measure the same. And at the bottom, this side, which is this side, measures the same as the other one adjacent to it. Okay, so two pairs of adjacent sides are equal in length. Beautiful. And says one pair of opposite angles are equal. Which angles are these ones? It says here is the ones that are between the sides unequal. So that's the one that are between the sides that are on equal length. So I know that this side and this side are not equal. Therefore, this angle and the one opposite are going to be equal in size. Great. And we have one last type of other type of quadrilaterals, and they are called irregular quadrilaterals. And this shape does not have any special properties. So it only has 4 sides, and that's it. It doesn't fulfill any of the conditions that we have studied thus far. Wonderful, girls. I hope you find this unit useful.